You have logits, which is the model's raw guess for every single possible next word. For some of these models, that step alone can eat up almost 10 gigabytes.
But memory's only half the story. The compute bottleneck is honestly even more infuriating. It's when your multi-thousand-dollar GPU, which is basically a supercomputer on a chip, spends most of its time just waiting. It's like you've got this incredible world-class factory, and the assembly line is just stopped all the time, waiting for parts.
And this gets us to a really key concept: being memory-bound versus compute-bound. You see, for a GPU to be used efficiently, a task needs to have high arithmetic intensity. That means lots of number crunching for every little piece of data it moves. But a lot of core AI operations have really low intensity. They're memory-bound, meaning the GPU is basically twiddling its thumbs, bottlenecked by how fast it can get data, not by its own incredible power.
What's making the GPU wait? Well, it boils down to two main culprits. First, every single tiny operation needs a command from the CPU, and each command has this little delay. It doesn't sound like much, but they add up to milliseconds of dead time on every single training step. Second is something called padding. AI models like to process text in neat rectangular batches, so shorter sentences get filled up with useless padding data. This means the GPU can spend up to 75% of its time just processing nothing. Pure waste.
Okay, so the problem is huge. We get it. So how do we fix this? This is where the Chronicles framework comes in. And it's not some single magic bullet. It's more like a super smart toolkit with 4 different clever optimizations designed to attack each one of these bottlenecks we just talked about.
So let's walk through the toolkit. First, they use something called fused kernels to cut down on all those commands to the GPU. Second, a trick called cut cross-entropy to avoid making that giant 5 GB logit thing in the first place. Third, a smarter way to fine-tune called LoRa+. And finally, they use sequence packing to get rid of all that useless padding.
Okay, fused kernels are just a genius idea. Instead of the CPU telling the GPU to do one tiny thing, then wait, then do another tiny thing, you just combine all those steps into one single command. It's kind of like the difference between a chef running to the pantry for flour, then running back for sugar, then back again for eggs, versus the chef just getting a list and grabbing everything they need in one smart, efficient trip.
Now, LoRa Plus is really cool. It's built on this simple but powerful insight. Not all parts of the model need to learn at the same speed. It turns out some of the parameters need to adapt way faster than others to sort of unlock the learning for the whole model. So by cranking up the learning rate, we're talking 16 times higher on one specific part, it just accelerates the whole process and can make the model learn twice as fast.
So the theory sounds great, but does it actually work in practice? Let's check out the results, because this is where Chronicles goes from just a clever idea to a total game changer.
And wow, this chart just lays out the raw speed. In a direct comparison, Chronicles is processing over 31,000 tokens every single second. That's a 2.73 times speed up over a standard setup in PyTorch, which is one of the most popular AI libraries out there. It just flat out gets more work done, period.
This chart is all about efficiency. The goal here is to be in the top left corner. That means you're super fast, which is high throughput, but you're not hogging a ton of memory. And look where Chronicles is, sitting right in that sweet spot, getting the best of both worlds compared to everyone else. This slide might be the most important one. It's basically asking, how much of that expensive GPU are you actually using? With Chronicles, that GPU is hitting nearly 40% of its peak power. Now compare that to another.
Interesting. I wasn't expecting Notebook LM to come up with that. I'll show you what I used for it. So I used the new web search feature and I searched for Unsloth and how it's how it can be used to fine-tune models on low-powered computers. That's what I put it in. But it's put in this instead, Chronicles. I mean, this is interesting. I haven't done any research on this framework. That's the only thing. I was hoping it would make a video on Unsloth, but this is saying that this is actually like almost 10 times faster. Sorry, 3 times faster.
Framework, Unsloth, which only manages about 11%. That's a huge difference. Chronicles doesn't let that expensive hardware just sit idle. But here's a wild discovery the researchers made while they were running these tests. They figured out that some of the crazy high performance numbers from the Unsloth framework were because of a bug. The model wasn't even learning. Its gradients were 0. It just goes to show how critical it is to really double-check these benchmarks and make sure things are working the way you think they are.
Okay, so we've seen these incredible results. A 4.1x speed up when using LoRa is no joke. But where is all that speed actually coming from? Which tool in the toolkit is doing the most work?
This waterfall chart is perfect for showing this. It breaks down how each piece adds to the speed. Look at that first jump. Just by using LoRa Plus with its different learning rates, you get an instant 1.5x speed up over the baseline.
And then the other optimizations, like the fused kernels and getting rid of the padding, they all just stack on top to get to that final 4.1x improvement.
And this pie chart gives us the same story from a different angle. Remember that simple but brilliant idea behind Laurel Plus, using a 16 times higher learning rate for just one part of the model? Well, that one idea is responsible for 35% of the total speedup. It's the biggest slice of the pie, by far, which shows how a deep insight can lead to a huge practical win.
So, we've gone deep into the problem, the solution, and the pretty amazing results. But let's pull back for a second. What's the big picture here? Why does making training 3.5 times faster actually matter in the real world?
Because look, this isn't just about code running faster. By cutting down the memory and the time it takes to train, this kind of work makes powerful AI available to way more people. It means a student in their dorm room or a small startup in a garage can now experiment with models that used to be only for the big tech giants. It levels the playing field. It democratizes innovation.
And that really leaves us with one big, exciting question. For the longest time, building the next big thing in AI meant you needed a warehouse full of servers. But if that's not true anymore, if training gets this efficient, then who gets to build the future? The answer is, it could be anyone. It could be you.
Okay, that last part I agree with. 100% agree with that. I'm actually looking at the Chronicles library right now, and this looks like it just released recently. As a matter of fact, just last month it was released. So yeah, last month. So this is for full fine tuning. So this is what I said. So as I mentioned at the beginning of that video was in conversation or in relation to full fine tuning, where you are completely overwriting what the model knows and adding your own intelligence to it. In that regard, yes, it can use a lot of memory, but you can see with Chronicles, you can achieve a 3.51x speed up over Unsloth's tokens per second. And in comparison, Unsloth does 11,736, whereas this will do 41,000 tokens a second on the same card, which is a 40 gigabyte graphics card. And I've used that card personally on RunPod, so I know the performance of that card. That's very impressive. And I will research this and I will cover this in more depth in another video. But for getting started, Unsloth is definitely the best. There's no denying that, because I'm really upset that it didn't use that. So I'm gonna deselect that. Yeah, I'm gonna deselect that source, and I'm gonna ask it to create another video. Get it to auto select this time. We'll do whiteboard. Actually, whiteboard's good. Okay, so we'll actually tell it to put some stuff in here, and we'll go focus on how good Unsloth is to get started with fine-tuning models. Okay, I'm auto-selecting.